Welcome back to video number 7 in our series on conceptual modeling featuring the ER diagram. Now that we've discussed some of the principles and structures of an ER diagram, let's start refining that database that we began with. Now we can refine this database design by changing the attributes that represent relationships into relationship types. The cardinality ratio and the participation constraint of each relationship type are determined from the requirements we discussed. The company is organized in departments. Each department has a unique name, a unique number, and a particular employee who manages the department. What information we store about the employee, and so on. If some cardinality ratio or dependency cannot be determined from the requirements, the users must be questioned further to determine these structural constraints. In our example, we specify the following relationship types. Manages is a one-to-one relationship between employee and department. Employee participation is partial. Department participation is not clear from the requirements. We question the users who say that a department must have a manager at all times, which implies total participation. Therefore, an employee may manage a department. A department must have an employee as a manager. Partial may be, total must be. The attribute start date is assigned to this relationship type. The works for relationship type is a one-to-many relationship type between department and employee. Both participations are total. An employee must work for a department, and a department must have employees. An employee works for one department. A department can have many employees. The controls relationship type is a one-to-many relationship type between department and project. The participation of project is total, whereas that of department is determined to be partial after consultation with users, indicated that some departments may not have any projects. A department may have many projects or none, and a project must have a department. The supervision relationship type is a one-to-many relationship type between the employee in the supervisor role and the employee in the supervisee role. Both participations are determined to be partial after users indicate that not every employee is a supervisor and not every employee has a supervisor. A supervisee may have one supervisor. A supervisor may have many supervisees. The president does not have a supervisor. The work zone relationship type between employee and project is determined to be many-to-many with an attribute of hours after the users indicate that projects can have several employees working on it. Both participations are determined to be total, meaning that every employee must work on at least one project, and every project must have at least one but can have many employees. Dependence of relationship type between employee and dependent, which is also an identifying relationship type. You see the double line? For the weak entity, dependent. Here we see the various symbols that are used in an ER diagram. This one indicates an entity. This is a weak entity, the double underline. This is a relationship. This is an identifying relationship, meaning that it is a relationship that identifies a weak entity. This is an attribute. This is an attribute, see the underline right there, indicating it's a key attribute. This is a multi-valued attribute, double lines. This is a composite attribute that's made up of other attributes, and total participation, cardinality rules, and so forth. When designing a database schema, the choice of names for entity types, attributes, relationship types, and particularly roles is not always straightforward. One should choose names that convey, as much as possible, the meanings attached to the different constructs in the schema. We choose to use singular names for entity types rather than plural ones because the entity type name applies to each individual entity belonging to that entity type. The authors of our textbook use the convention that entity type and relationship type names are uppercase characters. Attribute names have their initial letter capitalized, and role names are in lowercase letters. As a general practice, given a narrative description of the database requirements, the nouns appearing in the narrative tend to lead to entity type names, and the verbs tend to indicate names of relationship types. Attribute names generally arise from additional nouns that describe the entity types. Another naming consideration involves choosing binary relationship names to make the ER diagram of the schema readable from left to right and from top to bottom. We have generally followed this guideline. To explain this naming convention further, we have one exception to the convention shown here: the dependence of relationship type, which reads from bottom to top. When we describe this relationship, we say that dependent entities, bottom entity type, are dependents of relationship name and employee, top entity type. To change this to read from top to bottom, we could rename the relationship type to has dependents, which would then read as follows: employee entity, top entity, has dependents, relationship name, of type dependent, bottom entity type. Notice that this issue arises because each binary relationship can be described starting from either of the two participating entities, as we've already discussed. In general, the schema design process should be considered an iterative refinement process, where an initial design is created and then iteratively refined until the most suitable design is finally reached. Some of the refinements that are often used include the following. A concept may first be modeled as an attribute and then refined into a relationship, as we've already seen, because it's determined that the attribute is a reference to another entity type. It is often the case that a pair of such attributes that are inverses of one another are refined into a binary relationship. We discussed this type of refinement earlier. It is important to note that in our notation, once an attribute is replaced by a relationship, the attribute itself should be removed from the entity type to avoid duplication and redundancy. Similarly, an attribute that exists in several entity types may be elevated or promoted to an independent entity type. For example, suppose that several entity types in a university database, such as student, instructor, and course, each has an attribute department in the initial design. The designer may then choose to create an entity type department with a single attribute, department name, and relate it to the three entity types, student, instructor, and course via appropriate relationships. Other attributes/relationships of department may be discovered later. An inverse refinement to the previous case may be applied. For example, if an entity type department exists in the initial design with a single attribute department name and is related only to one other entity type, student, in this case, department may be reduced or demoted to an attribute of student. This is a good stopping place in this video. We haven't thought of a mystery word yet, and we've been discussing refining an ER diagram. So why don't we make refine our mystery word? So go ahead and submit your mystery word, check your knowledge for this video, and when you're ready, come on back to begin video number 8, and we will take a look at a different form of conceptual modeling.